Roman isn't just another space telescope, it's humanity's next great mission by NASA. By the time this telescope launches, it could completely change the way we understand our place in the universe. So let's look at the Nancy Grace Roman Space Telescope in detail. Hubble gave us breathtaking images of galaxies and nebula. James Webb showed us deeper into the past, capturing light that traveled for over 13 billion years. But there's still a massive gap in our knowledge. We know the universe is expanding faster than it should. We know most of its mass is invisible. It's dark matter and dark energy. If you do not know much about dark matter or dark energy, then I recommend you first watch the video I have left in the description. That describes it in detail. So, the Roman Space Telescope comes in to demystify dark matter and dark energy. Back in 2010, the US National Academic's Decadal Survey, a kind of wish list created by astronomers every 10 years, named a wide field infrared telescope as the highest priority. Roman is the result. Its entire mission is built around answering the biggest cosmic questions. Why is the universe expanding so quickly? What exactly is dark matter? And how common are planets like Earth hidden in the shadows of their star? The telescope was first called WFIRST, Wide Field Infrared Survey Telescope, but in 2020, NASA renamed it to honor Nancy Grace Roman. She was the first NASA's Chief of Astronomy, often called the Mother of Hubble. Roman fought for space telescopes when most people didn't believe in them, and without her, Hubble would never have flown. Naming this next great observatory after her is more than symbolic. It's a reminder that bold ideas need someone to push them forward. So, what exactly is Roman? On paper, it looks a lot like Hubble. Both have a 2.4 meter primary mirror, but here's the difference. While Hubble sees a tiny patch of sky at a time, Roman's wide field instrument can capture a view 100 times larger. Imagine looking through a straw versus a wide-angle lens. Hubble gives us sharper snapshots. Roman gives us entire panoramas. At the heart of Roman is a 300 megapixel camera that can see in visible and near infrared light from about 0.48 to 2.3 micrometers. That means it can trace galaxies, stars, and dust across a wide range of wavelengths. But Roman has another secret weapon, its coronagraph instrument. This is experimental, but potentially groundbreaking. The coronagraph is designed to block out the light of a star so we can directly image the faint planets orbiting it. To put that in perspective, it's like spotting a firefly next to a floodlight from thousands of miles away. If this technology works as expected, it could pave the way for future missions that directly photograph Earth-like worlds. The Roman Space Telescope is a survey machine. Instead of staring deeply at one point like Webb, it will sweep huge areas of sky. That wide coverage is crucial for three main goals. First, dark energy. Roman will observe hundreds of millions of galaxies. By studying how their light stretches and distorts, it can map large-scale structures of the universe. This helps us measure how fast cosmic expansion has changed over time. Roman will use supernova as cosmic mile markers and weak gravitational lensing to track the invisible scaffolding of dark matter. Together, these measurements might finally reveal what dark energy actually is, or at least narrow down the possibilities. Second, exoplanets. Roman will use a technique called microlensing. When a star passes in front of another star, its gravity bends the light, creating a lensing effect. If you have ever looked at objects through the bottom of a wine glass, for example, you've seen how light can bend and stretch things. This is exactly what happens. If that star has planets, the planets leave tiny fingerprints in the lensing signal. Roman will monitor hundreds of millions of stars towards the center of the Milky Way to catch these rare events. Astronomers expect Roman to find thousands of new planets this way, including ones as small as Mars, far beyond the reach of current telescopes. And with its coronagraph, Roman might even directly capture images of giant exoplanets, revealing atmospheres and properties we've never measured before. The third goal of Roman is time domain astronomy. Roman will be perfect for spotting transient events, things that flash, explode, or vanish in the sky, from supernova to kilonova. These fleeting signals are key to understanding how elements are forged, how stars die, and how black holes collide. It's natural to ask, if we already have Hubble and Webb, why do we need Roman? The answer is scale. Hubble has increased resolution, but its field of view is tiny. Webb can see deeper, especially in infrared, but again, only in narrow slices of sky. Roman doesn't see deeper than Webb, but it sees much more at once. A single Roman image will cover a patch of sky the size of 2 full moons, while keeping Hubble-like sharpness. Think of it this way. Webb is like a microscope, zooming into extreme detail. Roman is like a wide-angle survey camera, mapping huge regions to find the patterns, the hidden connections, and the rare events Webb could never stumble upon. Together, they complement each other. A mission this ambitious isn't without challenges though. One of the hardest tasks will be controlling systematics, tiny errors that can ruin precision measurements. For example, when Roman studies weak lensing, it needs to measure the shapes of galaxies with extreme accuracy. Even a small distortion from the instrument itself could throw off the data. The coronagraph is another challenge. No space telescope has ever flown with one this advanced. Engineers are pushing for contrast ratios of 1 part in a billion, blocking starlight enough to see planets a billion times fainter. If it works, it will be historic. If not, the main science goals are still secure, but humanity will have lost the test bed for future missions designed to image Earth-like worlds. The third challenge is the schedule. Roman is currently set to launch no later than May 2027 on a Falcon Heavy rocket. Space missions of this scale often face delays, but for now, the timeline is holding. The planned lifetime is at least 5 years, but like Hubble, it could run much longer if the hardware holds up. So, why should we care? Because Roman isn't about taking pretty pictures. It's about answering the deepest mysteries in science. Dark matter makes up about 27% of the universe, dark energy nearly 70%, and we don't actually know what either of them are. Roman could give us data to change that. And then there are exoplanets. For decades we've wondered, are there other Earth-like worlds out there? Roman could help us find hundreds of rocky planets orbiting stars like ours. It might even help us narrow down which ones deserve closer look by future telescopes and figure out which ones are habitable. So it's about legacy. Every time humanity builds a new tool to see the universe, we discover something unexpected. Hubble gave us proof of dark energy, Webb revealing galaxies we didn't think could exist so early after the Big Bang. Roman will almost certainly give us surprises we can't yet imagine. When Roman launches, the first few years will be focused on wide surveys, mapping galaxies, hunting supernova, and scanning the Milky Way bulge for micro-lensing events. Early results might include catalogs of thousands of planets, maps of dark matter stretching across billions of light years, and maybe even the first direct images of alien worlds using coronagraph. But the biggest discoveries may be the ones we don't anticipate. That's the history of astronomy. Every great telescope reveals things no one predicted. The Nancy Grace Roman telescope isn't just another instrument, it's a turning point. It's a moment we stop looking at single galaxies or single planets and start looking at the universe as a whole. It could rewrite the story of cosmic expansion, reveal thousands of hidden worlds, and test the very laws of physics. And when it does, we will look back and wonder how we ever lived without knowing it. So let me know what you think in the comments below. And as always, thanks for watching.